In this video, we're going to complete the KutaSoftware Infinite Calculus free worksheet, Differentiation with Natural Logs and Exponentials. So I'll leave a link in the description below so you know how to access this free worksheet. I'll also leave a link in the description below to my Patreon page. So click on that to find out more information about supporting my channel and becoming a patron. Now in this worksheet, we're going to differentiate each function with respect to x. But first, let's go over the derivative for a natural log and the derivative for e to the x. The derivative of the ln of x is going to be equal to 1 over x, and that's when x values are greater than 0. So the derivative of the ln of x equals 1 over x, and the derivative of e to the x equals e to the x. So knowing that the derivative of the ln of x is 1 over x and the derivative of e to the x is e to the x, let's jump into this worksheet. So in number 1, we have y equals the ln of x cubed. So we're finding the derivative of y with respect to x. And notice that we're going to need to use the chain rule for this because we have an outside function of ln of u, and then we have that inside function of x cubed. So for this, I'll go ahead and write out the chain rule since this is our first example with the derivative using a natural log. So we'll set y equal to the ln of u, and we'll set u equal to x cubed. So the derivative of y with respect to u is going to be equal to 1 over u, the derivative of the ln of u. And the derivative of u with respect to x is going to be equal to 3x squared. So when I take the derivative of y with respect to u and multiply that by the derivative of u with respect to x, I'll get the derivative of y with respect to x, which is what I want. Now the derivative of y with respect to u is 1 over u, and remember u is x cubed. So we'll have 1 over x cubed times the derivative of u with respect to x, which is 3x squared. I'll have 1 over x cubed times 3x squared. So that's going to be 3x squared over x cubed, which I can simplify using my law of exponents because 3x squared divided by x cubed is going to be 3 over x. And that's because x squared over x cubed is x to the 2 minus 3, which is x to the negative 1, which is 1 over x. And 3 times 1 over x is 3 over x. So our derivative in number 1 is 3 over x. Let's move on to number 2. In number 2, we're going to be utilizing the chain rule again. And since this is our first time taking the derivative of e within an example, I'll go ahead and write out my chain rule. So I'll have y equal to my outer function e to the u. And if y equals e to the u, then u will equal 2x cubed. So the derivative of y with respect to u is going to equal e to the u, because remember the derivative of e to the u is that same function e to the u. And my derivative of u with respect to x is going to be the derivative of 2x cubed, which 3 times 2 is 6, so that's 6x to the 3 minus 1, 6x squared. So my derivative of y with respect to x equals the derivative of y with respect to u times the derivative of u with respect to x. And my derivative of y with respect to u was e to the u. However, we know that u is 2x cubed. So we're going to have e to the 2x cubed as the derivative of y with respect to u. So you can see that original function times the derivative of the inside, 6x squared. And that's my solution for the derivative in number 2, e to the 2x cubed times 6x squared. Now in number 3, we're going to be utilizing the chain rule one extra time. So we're going to have the derivative of our outside, then the derivative, that middle function, And finally, that innermost function. So the derivative of y with respect to x is going to equal, looking at our first function, it's the ln of 2x to the fourth. And the derivative of the ln of some function is 1 over that function. So we're going to have 1 over the ln of 2x to the fourth. And then that will be multiplied by, now moving on to our middle function, the ln of 2x to the fourth. So that's going to be times 1 over 2x to the fourth, because remember, the derivative of the ln of some function is going to be 1 over that function, because the derivative ln of x is 1 over x. And that will get multiplied by the derivative of that innermost function, 2x to the fourth, which will be 8x cubed. 4 times 2, 8 times x to the 4 minus 1, 8x cubed. Now simplifying, I'll write this as 8x cubed all over 2x to the fourth times the ln of 2x to the fourth. So you can see that I have common terms in my numerator and my denominator. 8x to the third and 2x to the fourth can be simplified. 8 divided by 2 is a positive 4, so I'll have 4 in my numerator, and then x cubed over x to the fourth will leave me with an x in my denominator, because x to the 3 minus 4 is x to the negative 1, or 1 over x. So I'll have 4 all over x times the ln of 2x to the fourth. And that's my solution in number 3. Number 4 is very similar to number 3 in the fact that our outermost function is an ln, our middle function is an ln, and then finally we'll find the derivative of our innermost function. So the derivative of y with respect to x is going to be 1 over, because first we're looking at this outermost ln function, so that's 1 over the ln of 3x cubed. So 1 over the ln of 3x cubed, and that will get multiplied by, now we're looking at this next ln function, so that's going to be 1 over 3x cubed. And if we want to think of 3x cubed as u, ln of u, that derivative is 1 over u, and then we're plugging u back in, which was that 3x cubed. So then we've taken care of that middle derivative, and now we just have to multiply by that innermost derivative, the derivative of 3x cubed, which 3 will get multiplied by 3 to be 9, so we'll have 9 times x to the 3 minus 1, which is x squared. Now we'll simplify, and I'll simplify by looking at these last two terms. 3 goes into 9 evenly, that's 3 times, so we'll have 3 in the numerator, and x squared over x cubed is x to the 2 minus 3, which is x to the negative 1, which gives us 1 over x. So 1 over 3x cubed times 9x squared is 3 over x, but we're multiplying this by 1 over the ln of 3x cubed, so that's 3 over x times the ln of 3x cubed. That is our derivative, the derivative of y with respect to x in number 4. Now on to number 5. In number 5, again, we're going to be utilizing the chain rule multiple times. You can see our outermost function is the cosine of some function. Our middle term is the ln of some function, and then our innermost term, the most inside term, is 4x cubed. So a cubic function. So when we do the derivative of y with respect to x, we're first looking at that cosine function, the cosine of u. And remember, the derivative of the cosine of u is negative sine u. So we're going to have negative sine of ln 4x cubed. So now that we've taken the derivative of the outer, we're going to take the derivative of the inner, the derivative of the ln of 4x cubed. And remember, the ln of u is 1 over u. So the ln of 4x cubed is going to be 1 over 4x cubed. And now we'll take the derivative of 4x cubed, which 3 times 4 is 12. So that's 12 times x to the 3 minus 1, 12 times x squared. Now simplifying all of this, let's first look at our last two terms that are multiplied. 4 goes into 12 evenly 3 times, so we're going to have a 3 in the numerator. And x squared divided by x cubed is 1 over x. And now we just have to write the remainder of our numerator, which is negative sign of the ln of 4x cubed. So 3 over x times negative sign of ln of 4x cubed is going to be negative 3 times the sign of the ln of 4x cubed, and that's all over x. So again, negative 3 times the sign of ln 4x cubed all over x. In number 6, we have y equals e to the 3x squared. So our outermost function is that first e raised to some power. Our second function, or the middle function, is e raised to some power again. And then lastly, our innermost function is that 3x squared. So when calculating the derivative of y with respect to x, we're first going to look at e to the u. So the derivative of e to the 3x squared is simply e to the 3x squared. That's the derivative of our outermost function. Now our middle function is e to the 3x squared, and the derivative of e to the 3x squared is e to the 3x squared. Because remember, the derivative of e to the x, or e to the u, is e to the u. And then finally, that gets multiplied by the derivative of 3x squared, which 2 times 3 is 6, so that's 6x to the 2 minus 1, or 6x to the first, which is 6x. Now when simplifying, because I have the same base of e, I'll be able to add those exponents because the bases were multiplied together. So I'll have 6x times e to the 3x squared plus 3x squared. So e to the 3x squared plus 3x squared. And that's my derivative in number 6. 6x times e to the quantity e to the 3x squared plus 3x squared. So quickly in number 6, I'm going to write my exponent within parentheses so that it's easier to see that that entire quantity is an exponent. So this is e raised to that power. Moving on to number 7, my outermost function is e raised to some power. Then my middle function is some function squared. And my innermost function is that 4x cubed plus 5. So the derivative of y with respect to x is going to equal the derivative of e to the function, which is simply e to that function. So 4x cubed plus 5 squared. Then that will get multiplied by the derivative of 4x cubed plus 5 squared. So this 2 gets brought down in front, and then that value of the exponent decreases by 1. So it will be 2 times 4x cubed plus 5 to the first. And then lastly, I'll multiply by the derivative of that innermost function, the derivative of 4x cubed plus 5. This 5 is a constant, so the derivative is 0. Therefore, the derivative of 4x cubed is 3 times 4, which is 12. So that's 12 times x to the 3 minus 1, or x squared. Now, simplifying, I'll combine 2 with 12x squared to get 24x squared, and that will get multiplied by e to the 4x cubed plus 5 squared, and that term will get multiplied by 4x cubed plus 5. So again, this is 24x squared times e to the exponent of 4x cubed plus 5 squared, and that's all multiplied by 4x cubed plus 5. And again, in number 7, because the sizing is a little bit confusing and I'm not able to change the font, and writing smaller makes the numbers slightly more illegible, I'll make sure to put my parentheses around my exponent value of e. So this is e to the 4x cubed plus 5 squared, and then that entire term is multiplied by 4x cubed plus 5. But this is the exponent value. I just wanted to reiterate that so there's no confusion. Now let's move on to number 8. In number 8, we have y equals the ln of 4x squared times negative x cubed minus 4. So we can see here that we're going to be using the product rule. And remember the product rule, the derivative of y with respect to x is going to be the derivative of the first function times the second function. So we're going to have the derivative of the ln of 4x squared, and we'll be multiplying that to negative x cubed minus 4, and then adding that to our first function, the ln of 4x squared, times the derivative of our second function, negative x cubed minus 4. So calculating this out, we're going to need to use the chain rule for our first derivative. So we have the derivative of the ln of 4x squared. So the ln is our outermost function and 4x squared is our innermost function. So the ln, that derivative will be 1 over 4x squared, and then we're multiplying that by the derivative of 4x squared, which is 8x. And remember that all gets multiplied by that second function of negative x cubed minus 4. So we're adding that to the ln of 4x squared times the derivative of negative x to the third minus 4, which is times negative 3x squared. So simplifying this, I'll first simplify 4x squared and 8x. So that will be 8x over 4x squared is 2 over x. And 2 over x will be multiplied by negative x cubed minus 4, and then that will be added to negative 3x squared times the ln of 4x squared. However, I want to be able to combine these two terms and I need a common denominator. You can see that in this first term, my denominator is x. So I want this second term all over x, and in order to do that, I'll multiply that entire quantity by 1, and the one I'm multiplying by is x over x. So now I'll distribute this 2 to negative x cubed and negative 4. So 2 times negative x cubed is negative 2x cubed minus 2 times 4, which is 8, and that's all over x. And that will get added to negative 3 times x, and distributing this x to the numerator, we'll multiply x by negative 3x squared times the ln of 4x squared, because this is all one term, that x will get multiplied by x squared to be x cubed. So we'll have negative 3x cubed times the ln of 4x squared all over x. And again, that x is multiplied by this entire quantity. So now you can see that because I have my terms over a common denominator, I'll be able to simplify. So I'm adding my numerators together. I'll have negative 3x cubed times the ln of 4x squared, that second numerator, and then I'll add that to negative 2x cubed minus 8, which will be minus 2x cubed minus 8. And that's all over x. So the derivative in number 8, dy dx, is negative 3x cubed times the ln of 4x squared minus 2x cubed minus 8 all over x. Moving on to the second to last problem, number 9, I'm actually going to simplify this problem before I find the derivative. And I'm going to simplify by using the law of exponents. Remember, ln of some base to the exponent is the same as that exponent times the ln of that base. So y is going to be equal or equivalent to 5 times the ln of negative 4x to the fourth over x cubed minus 3. Now when taking the derivative of this, we have 5 as a constant. So remembering the constant multiple rule, that will be multiplied by the derivative of the ln of negative 4x to the fourth over x cubed minus 3. Now when taking the derivative of that, we have to use the chain rule. So we're going to use our outside function, that's the ln function, and then our inside function, or our innermost function, is negative 4x to the fourth over x cubed minus 3. So for our derivative, we're going to have 5 times, utilizing the definition of the derivative of ln, that's going to be 1 over that inside function of negative 4x to the fourth all over x cubed minus 3. And then that will get multiplied by the derivative of that innermost function, which we're going to need to use the quotient rule. Low d high minus high d low all over low low. So low is x cubed minus 3 times the derivative of high. The derivative of negative 4x to the fourth is negative 16x cubed. So here we have low d high, and we're going to subtract high d low. So subtracting that numerator of negative 4x to the fourth times the derivative of the denominator, the derivative of x cubed minus 3, which is 3x squared. And that's because x cubed, the derivative of that is 3x squared, and the derivative of 3 is 0. And that's all over, remember for our quotient rule, all over our denominator squared. So x cubed minus 3 squared. Now this looks like a lot, but just stick with me as we simplify this problem. Now we have 5 times 1 over negative 4x to the fourth over x cubed minus 3. But 1 over some fraction is the reciprocal. So we'll have 5 times the reciprocal of negative 4x to the fourth over x cubed minus 3 is negative x cubed minus 3 over 4x to the fourth. And that is multiplied by, in this next part, I'm going to split my fraction up because these terms are subtracted. And I'm doing so because I have x cubed minus 3, which will cancel out with x cubed minus 3, and I have some 4x to the fourths that will cancel out with 4x to the fourth. So when I split this fraction up, I'm going to split it up as my first term over my denominator minus my second term over my denominator. So that's going to be x cubed minus 3 times negative 16x to the third, which I'll write as negative 16x to the third times x cubed minus 3, and that's all over x cubed minus 3 squared, and that's subtracted by negative 4x to the fourth times 3x squared all over x cubed minus 3 squared. Now in this next step, I'll be distributing my negative x cubed minus 3 over 4x to the fourth to each of my terms within that polynomial. So I'll have 5 times, now note, when I distribute to my first term, x to the 3 minus 3 will cancel out with 1 x cubed minus 3 in the denominator, and then you'll see my other x cubed minus 3 will cancel out with the last x cubed minus 3 in the denominator. So this is essentially x cubed minus 3 squared over x cubed minus 3 squared, which is 1. So all I have is negative 1 over 4x to the 4th times negative 16x cubed, which is going to be a positive 16x cubed over 4x to the 4th. So now that I've simplified that first distribution, I'm going to need to simplify after distributing negative x cubed minus 3 over 4x to the 4th a second time, which now we're going to be looking at that last term. And in this case, x cubed minus 3 will cancel out with 1 x cubed minus 3 in the denominator, so I'll still have x cubed minus 3 in my denominator. However, now you can see that 4x to the 4th will cancel out with 4x to the 4th, or a negative 4x to the 4th if we apply that negative. So we'll have a positive 3x squared over x cubed minus 3. And remember, that's all subtracted. So we're subtracting 3x squared all over x cubed minus 3. And that's x cubed minus 3 to the first, not squared because we were able to cancel out one of those x cubed minus 3's. And the 5 gets multiplied to each of these terms. But before we do that, once again, let's simplify. So looking at 16x cubed over 4x to the 4th, that's going to leave us with 5 times 16 divided by 4 is a positive 4, and x cubed over x to the 4th will be 1 over x. So that's 4 over x, 16x cubed over 4x to the 4th simplified equals 4 over x, and we're subtracting 3x squared all over x cubed minus 3. Now in this next step, I want to be able to combine these over a like denominator. So in order to do this, 4 over x will be multiplied by 1, and the 1 is going to be x cubed minus 3 over x cubed minus 3. So I'm multiplying by the denominator of my second fraction. But then for this next fraction, in order to have a common denominator, I need to multiply by x over x. So we'll have 5 times 4 times x cubed minus 3 all over x times x cubed minus 3, and then we'll be subtracting 3x squared times x, which is 3x cubed, all over x times x cubed minus 3. Now you can see I'll be able to simplify. So this will be 5 times 4x cubed minus 3. I'll distribute the 4 to x cubed and to 3. So that will be 4x cubed minus 4 times 3 is 12, so minus 12. And then we're subtracting that other numerator, minus 3x cubed, and that's all over our same denominator because the denominators are now equivalent, hence why we were able to subtract those numerators, and that's all over the same denominator of x cubed minus 3. Now, finally, I can simplify combining 4x cubed and 3x cubed. So 4x cubed minus 3x cubed is going to be x cubed. So we'll have the derivative of y with respect to x equal to 5 times 1x cubed, so that's x cubed, minus 12 all over x times x cubed minus 3. So the derivative of y with respect to x after simplifying down in number 9 is 5 times x cubed minus 12 all over x times x cubed minus 3. Now let's move on to number 10. In number 10, just like we did in number 9, I'm going to simplify at the start to make finding the derivative easier. So I'm going to rewrite y equal to e to the 5x to the 4th all over e to the 4x squared plus 3 as, well, let's note that we have the same base and we're dividing those, so I'm going to subtract my exponents of that base. So I'm rewriting y as y equals e to the 5x to the 4th minus, so 5x to the 4th minus the exponent of my denominator, 4x squared plus 3. So that's going to be e to the 5x to the 4th minus 4x squared minus 3. Because we're subtracting that entire quantity, so we're subtracting 4x squared and we're subtracting 3. Now when finding the derivative, we'll use the chain rule. You can see that my outermost function is e to that inside function of 5x to the 4th minus 4x squared minus 3. So the derivative of e will be e to the 5x to the 4th minus 4x squared minus 3. Because remember, the derivative of e to the u is e to the u. So e to that function, 5x to the 4th minus 4x squared minus 3. And that's all multiplied by the derivative of my inside function, my innermost function, 5x to the 4th minus 4x squared minus 3. Well, looking at that, the derivative of 3, the derivative of a constant, is 0. So we're looking at the derivative of 5x to the 4th, which is 4 times 5, so that's 20 times x to the 4 minus 1, which is x to the 3, and then we're subtracting the derivative of 4x squared, which is 2 times 4, 8 times x to the 2 minus 1, x to the first. Now, you can see that I'll be able to pull out a common factor from 20x cubed and 8x, because both are divisible by x and both are divisible by 4. So if I pull out 4x, I'll have 4x times e to the 5x to the 4th minus 4x squared minus 3. And that quantity times, well, remember I pulled out a 4x from 20x cubed and 8x, so 20x cubed divided by 4x is 5x squared, and 8x divided by 4x is 2. So my derivative for my last problem, number 10, is 4x times e to the 5x to the 4th minus 4x squared minus 3 times 5x squared minus 2. And again, I just wrapped that exponent in parentheses so that you can see it is the exponent of e. Because sometimes when writing on my tablet, it's hard to see what is or isn't an exponent. So I just wrapped that in parentheses so you can see that that's e raised to that entire power. And with that, we wrap up our free KutaSoftware worksheet, Differentiation, with natural logs and exponentials. If you have any questions, please feel free to leave them in the comments below, and I or one of your peers will respond as quickly as possible. Also, before moving on, if you found this video helpful, give me a thumbs up, subscribe to my channel, and share it with someone else that you think will also find it helpful. And if you want more ways to support me, like I stated in the beginning of this video, go to my Patreon page and become a patron. Find out how to do that by clicking the link in my video description or going to maemap.com.